I had a nice slide for the beginning, but we don't want to have technical problems, so I'm just going to go straight to the editor. Here's a link on chat that you can git clone what I'm going to do here if you want to follow up. We don't have a lot of time. What I thought I'm going to do, because I gave a talk about, 2 talks about Rust in the beginning, in past Sub0 events, where I explained stuff and say again? Someone says they lost me. Can you hear me?
I can hear you okay. How about everybody else?
Okay, I'll carry on until someone else screams. So what I figured I'm gonna do is instead of trying to explain what lifetimes are and everything else, I'm actually just gonna show you what the lifetimes are and generics and traits. I'm just gonna go straight to the code. So in my main function here, the link is always in top here. In the main file that you can also clone, I have some modules with different chapters. We're gonna start with chapter 0 because we are programmers. I'm gonna uncomment this, and we already see there's something going on. I'm gonna try to run this, and I have private stuff. Let's make it public. Okay, we have some errors. So let's go here. And I should see, okay, so I have Rust Analyzer, which is great because it shows me errors from the Rust compiler right in my editor. So I'm trying to do something here. I'm running a function, and I'm trying to print a hello, and I'm trying to get a reference from a function, from a return value from a function, right? And I'm trying to return a reference to a StringSlice, and my StringSlice, I'm trying to borrow the StringSlice from a string, from an allocated capital S string, and my compiler is not very happy about this. And the reason my compiler is not very happy about this is because I did something very, very dumb, which is I'm trying to borrow memory from an allocated structure from this capital S string outside of this function, but this string will stop existing at the end of this function, right? So you can imagine that there is before this function exists, there's actually std mem drop string, something like this. Like the compiler kind of injects it here. Oh, drop, not drip. My configuration. This is Sublime text running Rust Analyzer. That's roughly it, and I have a terminal plugin just for this presentation. So it's not possible for me safely to borrow the string that is being destroyed at the end of this function into the return value. It is, however, possible for me to return a StringSlice, and the absolutely easiest thing to do is to just return the StringSlice itself. And I still have one error here. This is not very helpful, but I think if we run it here, the Rust compiler actually is very useful. It actually tells me what to do. So it goes here for this StringSlice, help consider giving it a static lifetime. Right? So let's give it a static lifetime. Okay, there's nothing underlined except for this because it's a typo. Let's try to run this again. Now we have over here, hello Sub0 has been printed. And this is the first tip of the talk is the static lifetime. So anytime you use double quotes to create some string inline, the memory where this Sub0 is going to reside when you're running this code is in the, it's loaded from the binary, right? And the static lifetime is like a special lifetime in Rust, which is the lifetime of the entire program. So this thing is basically forever, quote unquote. So this works. Why Rust doesn't automatically infer it as a static lifetime? That's a good question. So the problem is, if you're trying to do this, it doesn't know in the context of this function run. This function run doesn't know anything about this lifetime. So you can do something else, which I can give it anonymous lifetime, but I have to give it a name, which is just, I'm gonna name it A, and this will also work. I'm gonna click run, it works. And now I did something magical in TEKsystems. So both of those programs are now basically equivalent. They do exactly the same thing. They compile to basically the same assembly. But as far as TEKsystems is concerned, I actually did something very different here, because here I've declared a type parameter or lifetime type parameter of an anonymous lifetime, and then I'm returning my StringSlice which is a static StringSlice with an anonymous lifetime A, and this lifetime will now I don't know if you can see it here. Yeah. So this lifetime will now function within the function run. And Rust will infer a lifetime. So if I had a parameter here, like it had like some self, if it was a method, right? And I was returning a string from self, then basically what Rust does for inferring is it will look, okay, I have a reference here and I'm returning a reference. So Rust will go, okay, what you're probably doing is you're borrowing something from this borrow, right? So it will then automatically do this stuff. But because I don't actually have any parameters here that I could borrow stuff from, I need to actually inform it that, hey, you can actually borrow it from the anonymous lifetime. And the important thing here is that the magical thing that happened is I have this static lifetime, which is the longest lifetime possible. I have narrowed it down to this anonymous lifetime, which is going to just live for this one function. That's clear. If there are any questions, feel free to ask them in the ask a question or whatever. We can come back, but I think it's going to be clear when we go to the next example. Let's make sure this still runs. We don't have any errors here now. Okay. So chapter 2. This is going to be more fun. Okay, so I have defined a struct here, slices. The struct contains a vector of string slices with some lifetime. So this struct has a lifetime that matches the lifetime of the slices that are inside it. And I've made some two methods on it. There's a method called slice, which takes a string slice and returns the struct itself. And what I do here is I take my text, which is my string slice. I call split whitespace, which is an iterator provided by standard library. And then I call collect, which is also a method on all iterators that will turn my iterator of string slices into the tag. Dr. Sensor says, I thought anonymous lifetimes annotated as underscore. That is true. Actually, you're correct. This is actually not an anonymous lifetime. This is a named lifetime. But the point of it is it's a lifetime that is not mapped to anything except for the lifetime of this function. Or it lives for the body of this function. That makes sense. Okay. So back to our example here. So we're going to collect this the string sizes. So we're going to split the text by spaces, and we're going to collect the stuff. And then I have some code over here. I'm going to create a string, capital S string on a heap. And I'm going to read some stuff from terminal. Then I'm going to create my slices, and I'm going to try to print them out one word at a time. And this should work. So let's try that. And we have our previous hello 0. And let's say, what do we write? Hello Sub0, this is a talk about lifetime generics and traits. Cool. So we've printed all the strings. Now if you go back over here, this is a review, this is an overview of Rust, like intermediate level, roughly. Okay. So the thing to note over here is that I have my vector of strings, and the struct slices owns the vector, but the vector borrows string slices from, in this case, this string, capital S string, right? So I create my slices here, and I'm iterating through them over here. But what I'm actually doing, what I'm actually printing out is still contained in this capital S string over here, right? So I've read from the terminal, I've read some input into this capital S string. And while the vector is allocated on the string slices, what I'm actually printing here, the word over here, is still borrowed from the string here, right? Makes sense? So the lifetime is, and this is the important thing, the lifetime, what a lifetime is an information about this reference points to some memory, and this memory has to exist for a specific amount of time in my program, or my program won't compile, or it has to be guaranteed to live for long enough. It is indeed Rust the weird piece. So lifetimes are actually not a Rust thing at all. Lifetimes are actually just a property of how computers work and how memory works and how allocations work. And you actually have lifetimes in C and you have lifetimes in C++. The only way to not have lifetimes or not have to think about lifetimes is to have a garbage collector, right? Where you have managed memory. You have lifetimes in C and C++. The only problem with C and C++ is the lifetimes are actually not, well, to some degree they are now in modern C++, but they aren't enforced on compile time. So the unique thing about Rust is it's not that the Rust has lifetimes, because that's not actually what Rust has. What Rust does is Rust enforces that your lifetimes are actually correct at compile time. So you don't have to incur garbage collector costs at runtime. Okay, so let's try to do something else. So let's try to write something to my string before I iterate. So I'm going to try to push another string on my input, and I'm going to get an error. Let's try to put it in the terminal. And this is something you're probably going to see a lot, which is I'm borrowing my input here, immutable borrow, and when I create my slices, then I make a mutable borrow of my input, but later on I still have my immutable borrow over here, right? So this input here, this capital S, I'm trying to mutate it, I'm trying to add something to the end of it, while this exists, right? And this exists because I know that the slices have a lifetime, and this lifetime points to this reference over here, that this is therefore illegal, quote unquote. And the reason why it's illegal is actually, there's a good reason. Pushing something to the string can cause a reallocation. And if I reallocated the string, which means the content of the string have moved in memory to a different address, right? And I have a vector of references to strings, which still point to the old address, which now would be taking pointers, right? And I would have undefined behavior in my code. This is perfectly fine C++. This is completely incorrect Rust, which is cool. But one thing I can do is I have this method add over here. So if I make my words mutable, I can do words add, not as, foo at the end. Words. Okay. I can try to run this. Compiles it runs. Hello, Sub0. And I've printed hello, Sub0 and foo. And this is also cool because, again, I'm using the trick. I'm using the fact that this foo over here is living for the static lifetime. This slices thing lives for the narrow lifetime A, and I can pack my static lifetime, which is wider, into a narrower lifetime, and Rust is happy. I can't do the other way around. I cannot, if this was static and I had a narrow lifetime A, I wouldn't be able to put it in the struct. But if I have a narrower lifetime, I can put it in a container that requires a more specialized item, if that makes sense. So, just looking over the chat, I think we're good. We really don't have a lot of time, so I'm just going to leave it. Actually, it's here. Okay, disjoint borrows. That's going to be fun. I'm actually not going to run a new code over here. I'm just going to show you the errors. So this is something I thought I'm going to show you because it's a pretty common problem that you're gonna that you can trip yourself in. So I have a struct foo. There are no lifetimes here. There are just no declared lifetimes, right? This is just I have like some mute references. Everything is owned. Everything is owned and everything's fine. But I have an error over here. Let's see the error in the terminal. The error is I have one mutable borrow of self, and then I have a second mutable borrow of self. And I am trying to do something, right? Let's go back over here. So I have two vectors of numbers, of integers, and I'm trying to get two mutable references, right? One from vector 1, one from vector 2, and I am trying to add them to each other. And then that's it. That's all I'm trying to do. And Rust doesn't allow me to do that. And the reason why Rust doesn't allow me to do that is because I'm actually using a method. I'm using this helper methods that I wrote here, which for this helper method, I'm borrowing self in order to get something from the vector. So my A over here lives with the same lifetime as my reference over here. And the simplest thing you can do is to completely get rid of this, right? And you vec1, vec2. I'm just going to do get mute. And now this is going to compile. It's not going to do anything because I'm actually not producing anything. But this compiles. The reason why this compiles is, again, this is still just mutable references. There is no lifetime annotations here. But I can borrow a field from a struct and then borrow a different field from a struct. And I have two disjoint mutable borrows inside my struct. So when you're making writing methods for structs, it's very common if you're trying to mutate two things in your struct, you will want to split your mutable references into different fields of the struct this way, and this way you can avoid all the problems where Rust will complain about your mutable references overlapping, if that makes sense. And okay, let's jump next. I don't see questions. Oh, there's one question. Does asterisk B as pointer B is so ampersand B is, I believe it's the same as C, but it's basically the variable A points to, well, this is not very helpful, but the variables A and B are ampersand mute I32. And I want to, if I do this, right, it's going to complain. I'm trying to add ampersand mute I32 to I32, but what I actually want to do is I want to add the number, not the, I don't want to add the reference or the pointer, I want to add the number. So the asterisk negates the ampersand, if that makes sense. And the same here, because I need to negate yes, exactly, dereference the reference to have the value, complete value. Okay. So that's lifetimes in shortest amount of time. Let's go to generic. So we have generic function. Yes. So I have a generic function here. I want to do something here. It's hopefully going to be cool. So I want to be able to do something like this. I want to call my function print from my module over here, and I want to be able to call it with a string slice or an integer, right? And the way I do this is I already have a type parameter over here, which I'm going to use here. So I'm using a generic type t. I don't know what the type is. I'm trying to print it. And luckily, Russell tells me what it is it actually wants me to do is, in order to use the curly braces here in the print line, I need to implement the display trait, which I'm just going to quickly do. And this is now going to work, which is kind of cool. Let's see if on terminal. Let's see if this works. Cool. So I have hello to 0 and 42. Over here. Actually, let's go back, look at main. And I think here you can see, yes. So here you can see I have a function print. I'm calling a function print with type parameter StringSlice. And later on, I'm calling the same function, but with type parameter i32. And what's actually happening here is that the compiler will generate two separate functions print, but one is for string slices and one is for integers, right? So I'm actually duplicating the function. This is in C++, this is called templates, which is also a reasonable name for this kind of stuff. But this is basically a template, right? This is a template for a function. This is a generic function that doesn't actually exist until I call it with some type parameter, and then it will be created for the type parameter once. We have some more questions. When a lifetime A starts and ends exactly in your code? Oh boy. It really depends on where you are, but basically, if what we are doing is, let's go over here. When I have a string here, right, I'm borrowing it here for some lifetime, and then I'm borrowing it again, the same input, I'm borrowing it later here. By now, Rust is smart enough to know that, hey, okay, because I'm using this reference over here, and then I'm done. Whatever this thing did, this read line, whatever it did, it's done over here. Like at this line 27, this reference is no longer needed. So I can borrow the input again as an immutable reference, right? So this reference only lives for this one line, effectively. That's how we can think about it, right? If I were to do something if I store this reference in a variable and I used it over here, then that's how long it would have to live. Okay, we are like at the edge of the time. I'm just gonna quickly rush over this because I think this is probably cool. Let's slide over this. Let's try chapter 4. Okay, let's see what's our output in the terminal going to be. Right, so we have some errors. So I have a struct with a generic type parameter t, and I'm trying to implement a trait display for my hello. The error here is that I need to put my t over here. All right, it's cool. This is fine. So I can instantiate my hello with the parameter t. And for the display, I'm also missing it. So I need to, again, define the type parameter for the impl, define the type parameter for the struct, because it's needed. And here, again, we will complain as the same thing as before, that I need to do a trait bound on display. So put it over here. So I'm implementing display for hello, for hello of t, for any t that implements display itself, right? And then I'm going to print hello with whatever what is. All right, and then I'm going to try to create two hellos, and I'm going to try to print them out. and it works. So this is the first example from the first thing, and then these are the actual 2 impulse that I did. And then I still have two more chapters, but we are kind of on time. So I think we're going to take a break, and I'm going to be in Discord to answer questions. And I think that's, we can, if anyone is following through, I'll be there to answer questions.